Okay, so our topic is the priority scheduling algorithm of the CPU. So there's a problem here. Consider the set of processes with arrival time in milliseconds, CPU burst time in milliseconds, and priority shown below. So there's a note, the higher number represents higher priority. So we have here the process ID, the arrival time, the burst time, and the priority. So P1, the arrival time of P1 is 0, and then the burst time is 4, and have the priority of 2. And then P2 have the arrival time of 3, burst time of 2, and priority of 4. Then the P3 have the arrival time of 4, burst time 5, priority of 3, and so on. So if the scheduling policy is priority non-preemptive, calculate the average waiting time and average turnaround time. So our main objective here is the average waiting time and the average turnaround time. So how do we compute the average waiting time and average turnaround time? So first, let us copy the table, and then here's the solution. We need to create the Gantt chart. So the first process that arrived to the CPU is the P1, which is have the arrival time of 0. So when P1 arrives, there's no process in the CPU. So we have the non-preemptive algorithm. So P1 will be the one processed. And then the P1 have the burst time of 4 milliseconds. So even though the priority is only 2 and then the P2 is 4, the one that will be processed is the P1 because it is the first one that arrived to the CPU. So when P2 and P3 arrive during the process of P1, which has the burst time of 4, P2 and P3 will be processed only after the process of P1 will be completed. Okay, so after 4 milliseconds, P2 and P3 already arrived to the CPU. So let us decide which of the process will be processed by the CPU first. So let us look on their priority. So there's a note on the start of this video that the higher the number of the priority means higher priority. So P2 has the priority of 4 and P3 has the priority of 3. So P2 will be the one that will be processed first, and then P3 will be next. So P2 has the burst time of 2, and then after P2, 6 seconds already pass. So in the 6 milliseconds, P4 already arrived at the CPU. So let us look again in the priority which is higher. So P3 has the priority of 3, and then P4 has priority of only 2. So P3 will be the next that will be processed. So the burst time of P3 is 5. So 5 milliseconds. So P3 will be completed at 11 milliseconds. So after 11 milliseconds, P5 already arrived at the CPU. So we will look again on the priority which will be the next that will be processed. So P4 has the priority of 2, and then P5 has the priority of 5. So it will bypass P4 and then go to P5 because it has the higher priority. So P5 will be the one that will be processed on the CPU with the burst time of 9. So after 9 milliseconds, a total of 20 milliseconds, it will go back to P4 because there's no other processes left. So P4 has the burst time of 1 milliseconds and it will be completed at 21 milliseconds. So our main objective here is to compute the average turnaround time and the average waiting time. So to compute for that, we have to compute first the turnaround time and waiting time for every process. So how do we do that? So we have substituted here the values of the completion time, and by that we can compute the turnaround time and the waiting time. So for P1, we have the values of 4, which is the completion time, and then the arrival time of P1 is equal to 0. So we have the formula here. The turnaround time is equal to completion time minus arrival time. So 4 minus 0 is equal to 4. So 4 is the turnaround time for P1 or the process 1. Next, the P2 has the completion time of 6 and then arrival time of 3. So using the formula again, 6 minus 3 is equal to 3. And then P3, 11 completion time, and then the arrival time is 4. 11 minus 4 is 7. P4, the completion time is 21 and arrival time of 5, and the difference is 16. The P5 with the completion time of 20 and arrival time of 8 equals 12. So that is the turnaround time for every process. And then to compute for the waiting time, we have the formula turnaround time minus burst time. So substituting, the turnaround time of P1 is 4 as we have found out here earlier, and then minus the burst time of 4 is equal to 0. So the process 2 with the turnaround time of 3 minus 2 with of its burst time equals 1. P3, 7 minus 5 is equal to 2. And then P4, 16 minus 1 is equal to 15. And then P5 is 12 minus 9 is equal to 3. So how do we compute the average turnaround time and the average waiting time? So we have the formula. We add all the values of the turnaround time divided by the number of processes. So we have 5 processes. So we add the values of turnaround time. 4 plus 3 plus 7 plus 16 plus 12 equals 42 divided by the number of processes, which is 5, is equal to 8.4 milliseconds. So that's the average turnaround time. How about the average waiting time? So same formula, we add the values of the waiting time divided by the number of processes. So substituting, 0 plus 1 plus 2 plus 15 plus 3 is equal to 21 divided by the number of processes, which is 5, is equal to 4.2 milliseconds. So the average waiting time is 4.2 milliseconds. So note that this is the non-preemptive priority scheduling algorithm of the CPU. So whichever process arrives first So that will be the one that will be processed. Uh, that's all, and thank you.